welcome everybody. Well, I guess we'll just get going here. We have some interesting speakers today. I think this is going to be a lot of fun. I always like this kind of out on the edge, innovative stuff, so this should be fun. I'm Dick Slansky from ARC, and we're going to take a look at the product design aspect of IoT. Even though and then we move to the factory, it's a little bit more IIoT, which is, so stick around for the second half of this, because we're going to talk about the factory, the smart connected factory of the future, and we're going to talk about product design in this session, and all centered around this notion of smart connected devices, products, equipment, whatever. And there's a lot of technologies moving around that. I'll kind of go into this. So I'm going to make this relatively brief, kind of an overview of what this topic is, and I'm going to let the speakers take care of going into more of the detail on this. But the basic theme here I want to talk about in this particular session is the product, the way we design product is being fundamentally changed by the Internet of Things. So let me move forward here. Okay, so it's no secret that the current Internet of Things environment is on us. It's on us with a vengeance, and it's going to continue to really, really accelerate. And we're talking about consumers. We're talking about industries. We're talking about all aspects of society that this is going to affect. So it's forecasted, and this is, I think, pretty conservative forecast, that in 4 years now, it's funny how this creeps up. In 4 years, we're going to have 50 billion objects, and this really is about objects. So this is connecting, as I said, across business, industry, residents, consumers, and this is going to require complete rethinking and refocus of our product design criteria. I think the PLM companies, in my opinion, are really leading the way in this whole Internet of Things and industrial Internet of Things era that we're moving into, because they're providing they're at the spear point of this. It's the products, and it's the products that will form the factories and the equipment and so forth. So it's the design of that that's going to drive this. So basically today we're going to talk about the two basic elements of Internet of Things: connected objects and smart products. So with the emergence of Internet of Things, as I said, this is going to require a completely new design paradigm. As good engineers, as good product engineers, in whatever industry we're from, we always subscribe to this basic traditional approach of good design was all about fit, form, and function, and no matter what the criteria was. And that really drove product design for a long, long time. As we move into this new era of Internet of Things, the requirements for IoT are going to change that. We still need to design for fit, form, and function, but we're going to have to add in those new elements of designing to include connectivity and to include intelligence. And moreover, we're going to have to look at how these products that are going to make up the Internet of Things will add value to the ecosystem that they're going to be a part of. I'll talk about that in just in a minute here, about the systems of systems. And it's really all about the service life also. The service life cycle is a new dimension that is incumbently dependent on the smart connected product. And so we're going to go through kind of a phase here. We're going to add intelligence. It's not that intelligence in embedded systems embedded intelligence is anything new. And it's not that we don't have smart sensors and haven't had that kind of stuff. But it's really about the scope of the thing, the holistic manner of the thing, that everything's going to be connected, and it will enable a whole new era of predictive, prescriptive, and as I point out here, leading to complete autonomy. Hold on to your hats. So I brought a little graphic here from the guys at PTC to kind of look at this. But basically what I'm saying here is that we have to design to support the Internet of Things ecosystem. It's like I said there, systems trump components now. Nothing stands alone. And this is the criteria that we're going to have to live by in design. So basically it's a simple product, like a tractor, and then you put some sensors and some things in it, and it's a smart product. And then you connect. You create connectivity, so all those smart sensors and stuff start. We have a way to connect to them, and then that simple tractor becomes a system with all the other implements and all the other functions that it does and everything, and then that becomes a system of systems, and this is where we're really going. And this is all going to be about a system of systems and basic systems engineering design. So with these connected objects, things, devices, they can intelligently communicate their state and their condition so that service can be performed. And that's ultimately what we want to do. We want to extend the product lifecycle from design, build, operate, maintain to beyond the walls of the factory, out into the service, out into the field and into the environment, and keep them maintained and serviced. So that's part of this. So if IoT is driving a new design paradigm, the product designer is going to levy some new requirements on the product designer. So they're going to have to move beyond this concept of creating a non-connected standalone product, which is something that we've done for a long, long time. Design within the broader context of connectivity, and more importantly, you will increase the intrinsic value of this connected product that it will bring to its own environment and its systems, its ecosystem that it's working within, that it's functioning within. So this new design paradigm means that we're going to have to look at designing to combine the physical product with the virtual. We're going to create a product that's to be accessible on the cloud or physically off the shelf in the factory at any rate. And I'm going to talk a little bit about this notion of the digital twin briefly here. So the emerging so what we have is this emerging smart production environment or ecosystem, as I said. So it's not just the product that's going to be connected in this smart connected ecosystem of things, ecosystem of systems. It's going to be connected supply chains, a connected worker. They're going to have augmented reality and all kinds of really cool. There's some really interesting things out there right now in terms of technology and that space that's emerging. And then the factories themselves will all be connected together, and there'll be a decentralization of the factory, and the factory's supply chains will all be connected and holistic in a sense. And this is where we're really we're wanting to strive to from the very beginning. So it really will be the connected enterprise, or the digital enterprise, whatever terminology is starting to emerge out there. A great example, I don't have to explain this excuse me. I don't have to explain this in great detail, is the car. Ford Motor Company recently said at the Detroit Auto Show, they said, we're not going to build vehicles or refer to this as vehicles anymore. This is going to be mobility systems and connectivity systems and ecosystems on four wheels. It just happens to be mobile itself. And I think that's really the case. So as you can see, there's a whole array of connected systems within the system. So the car itself is really a system of systems. It's connecting outside. It's connecting to the driver in terms of driver awareness and other systems. It's connecting to road awareness systems. It's connecting to the maintenance and the service of the car. If you're driving an electric vehicle, it's going to start telling you where the closest charging station might be. That's probably going to be fairly essential. And all kinds of other things. So this isn't the future. Obviously, you all know that. This is now. This is where we're at now. And truly, it is a system of systems. I'm going to keep using that term. You're going to hear a lot of that term because I can't emphasize that enough. So this connected asset and it is an asset. It's a product, but it's an asset too, depending on how it's used and the viewpoint of where it's at and within the context of the ecosystem. But you can see there's a whole host of stakeholders here: the manufacturer, the user from the engineering perspective, the user from the maintenance perspective, the user from the operations perspective, the EPC that builds the buildings and the plants, the manufacturer that manufactures the cars and the airplanes and the washing machines and all, and your Fitbits and everything else. So, and then there's the whole notion and the whole concept of service and maintenance, which is really a big part of this, and this is where we're going to go with this. So what we're looking at is what are the connection technologies that we should support? I mean, in terms of design criteria, what sensors and data should the product expose? What intelligence does the product require? What's the performance, the data selection? What kind of the details of the communication? Everything is now, this is a part of the design criteria now. So we have manufacturers and OEMs, maintenance service providers. On one side, we have end users, and they are the recipients of the operations and the maintenance and the engineering and the service, and they act as service providers. So again, when you're designing your product, you're designing your equipment, you have to consider who are the players in the ecosystem, what are the connection technologies that are going to be needed, what are the sensors that are going to be needed, and so forth. What does the intelligence expose, and how can you use this, and how can you increase the intrinsic value of the product itself? This is a maturity model that we have developed at ARC. I'm not going to dwell on this too much, but basically you can see a progression here of level of maturity versus added value on one side, on one axis, and the level of maturity on the other axis. And as we've gone from conventional to instrumented. We've had instrumented for years and years. We've gotten to software definitions. Now we've gotten smart. We have embedded intelligence. We have self-optimization. We have machine learning. And ultimately, we're going to go to autonomous. So we're talking about the virtual twin, prescriptive analytics, and new business models. That's another thing we're going to talk about. Digital twin. So basically, the digital twin is a virtual replication of an as-designed, as-built, and as maintained physical product that we currently have, that we currently use, and using the same engineering design principles that we all know. This can be augmented by real-time condition monitoring and predictive analytics. So the digital twin is the twin. As you can see, there's the digital twin, and there's the physical the wind generator. And the digital thread is this thread of information, design information, of operational information from the virtual to the physical and across the entire life cycle of design, build, operate, maintain. So it is a life cycle, and that is the thread that follows through that entire life cycle. So we at ARC have been using this slide. I've adapted this so that you can, down here at the bottom, in terms of business models, the traditional business model shows that we have equipment plus services, and we have to go through and operate and maintain, and we get an asset performance out of a piece of equipment. With the emerging business models, that digital twin will can completely change that business model. So the companies are starting to look at retaining ownership of their equipment, providing maintenance and updates and so forth, and through the digital twin, the notion of digital twin, and retaining the equipment altogether and just providing a service, and their users can subscribe to the service. Just like it's the same thing that the jet engine guys have been doing for years with power by the hour. This model is going to move around to all types of companies and their equipment I maintain. So this is just a quick graph here showing the kind of the capabilities of IoT maturity, and using this spider chart, you can use this to kind of chart a little bit about how using versus investing versus monitoring and evaluating is going to progress and grow. So that's basically what I've got. I'm kind of trying to wind this up. We have a blog, an IoT blog, and an industrial IoT viewpoints blog. I urge all of you, you've probably seen this on several occasions from other presentations earlier, but I urge all of you to look at this. We try to all contribute. Many of our ARC analysts are contributing this. We get guest contributors, so it's really taken off. It's really a good source. So that's it for me.